Hello and welcome to the channel Understanding.Concepts.Of.Physics. Hope you all are doing well and your preparation for the exams are going well. Just keep following the videos in case if you are missing with some of the topics. I have been doing so many videos on few of the topics: kinetic theory, thermodynamics, oscillations, few topics on logarithms as well. You can just check the playlist, and in case if you are weak in that particular topic, you can just go back to that topic again and again and keep doing it. Today we are again continuing the same topic which we started yesterday. In the previous video we discussed few terms in oscillation, and that was the amplitude, oscillation, time period, and frequency. So these were the terms and terminologies frequently used in oscillations, and there were two terms very special in oscillation, and those terms are called as phase and the initial phase. So we'll be using these two words now and then, again and again, in the following topics. So make sure that you have a good grip on these two terms. So let's just quickly start today's video with phase. So what is this phase? So that I have prepared a note, you can just take a note as well. Phase is a physical quantity. So you know what a physical quantity is. Physical quantity is a quantity which can be measured. A thing which can be measured is called as a physical quantity. So phase is also a physical quantity, it can also be measured, that describes the state of oscillation. And when at any given time t. So at any given time you can describe you can have this state of oscillation of a body in oscillation, and that is what is called as phase. So if you want to do it in short, you can say like this: phase of a body. Phase is basically defined as a physical quantity that describes the state of oscillation. Phase is a physical quantity that describes the state of oscillation at any given time t. That's what the definition is. So phase is a physical quantity that describes the state of oscillation at any given time t. Now, to understand what state of oscillation is, let's try to understand what state of oscillation is. State of oscillation is basically the magnitude. It's basically the magnitude and the direction of displacement. So when the body is oscillating, if you know what's the magnitude and what's the direction of the displacement, you can find out the phase. And what could be the third point for the point of phase is, in other words, in your equation of x is equal to a sin omega t plus alpha, this is one of the equations which we have derived in the previous classes, and this is an equation for displacement. So in this, the omega t plus alpha is what is called as the phase. So this angle is basically the phase, and since it is an angle, the unit for this angle, the phase, would be radians. So phase ka unit is radians, and because it's an angle, it's a supplementary quantity, and if you'll see, it's a dimensionless quantity. So it does not have any dimensions, but it does have its unit, and that unit is radians. Now mark this word, that this omega is your angular velocity or angular frequency, and t is time, and alpha was the angle which was made initially. So if you remember the previous one topic where I have discussed about the linear simple harmonic motion as a projection of UCM along any diameter, then this was that angle alpha, and omega t is this. So our phase is omega t plus alpha. So if you know what omega t plus alpha is, that means you know this angle. Now suppose if this angle is 135 degrees, or you can say in radians as well, then this angle, if you know, then you can understand where the particle is. And suppose I give you the omega t plus alpha ka value as 90 degrees, then you know the particle is over here. Since if I give you the value of omega t plus alpha as 270 degrees, then you know that the particle has gone from here to here, and the particle is as of now this point. So basically this omega t plus alpha shows you where the particle is going to lie. So even if I know where the omega t plus alpha comes out to be, let's say 300 degrees, then the particle has gone somewhere around here. It's 60 degrees behind from the x-axis, 30 degrees ahead from 270. So when the particle is at 300 degrees, somewhere around here, That means the projection, if along the x-axis the particle appears to be over here. So what happens is you know where the particle is, the way the displacement would be. So that happens if you know the phase. So phase is basically the physical quantity that describes the state of oscillation at any given time t. State of oscillation is the magnitude and direction of displacement, and in the equation of x is equal to a sin omega t plus alpha, omega t plus alpha is called as phase. Because it's an angle, its unit is radian, and it is a dimensionless quantity. Now if you have understood what phase is, initial phase is not a problem. It's just exactly same, just replacing some keywords. So phase becomes initial phase. So phase becomes initial phase. I have just copied and pasted over here and just changed only the things which has to be changed is put in green. So phase comes out to be as initial. So initial phase is a physical quantity that describes the state of oscillation. But the difference is initial phase is at initial time. Initial time means when the time is 0. So initial phase may you have t is equal to 0. However, in phase you have at any given time t. So that's the difference between initial phase and the phase. So initial phase name itself is it is initially, and when you talk about initially when the time is 0. Then this remains same. State of oscillation is nothing but the magnitude and direction of the displacement. And then in other words, the equation of x is equal to a sin omega t plus alpha. This alpha, why is it big? Because when you say omega t plus alpha and when you say when time is equal to 0. So if time is equal to 0, I have omega into 0 plus alpha, because I have put time ka value as 0. So I get only alpha. So alpha is equal to called as the initial phase. So initial phase is nothing but alpha. So that's the reason I have mentioned that alpha has to be a very special constant. That's why I have not written it C when I was deriving displacement. That's why. And today we know that this alpha is nothing but initial phase. Then lastly, the next point is very simple. Since it is an angle, the unit is radian, because this has to be an angle, this has to be an angle. And it's a dimensionless quantity because it's an angle, it's a supplementary quantity, and supplementary quantities are those quantities which have units but they don't have dimensions. Okay. However, there is one more point extra over here, and initial phase is known by so many names. Initial phase is also known as starting phase. It is in some books you will find out it's called as the beginning phase. But these two names are pretty confusing to students. It's also called as phase constant. So if phase constant is given as pi by 3 radians, you should be knowing phase constant is basically your initial phase. Sometimes they also use this very old name called as epoch. Now epoch is also something called as initial phase angle. So if your board utilizes some of the other words from here, then make sure that they are mentioning about the same thing, that is the initial phase. So with this knowledge of initial phase, amplitude, oscillation, time period, frequency, we are going to solve we are going to actually do graphical representation of oscillation of linear simple harmonic motion in our next video. So just keep watching the videos. Next two videos will be graphical representation, and then we'll move on to composition of SHMs and kinetic theory, kinetic energy, potential energy. Thank you so much for watching. If you are still with me, subscribe the channel in case you have not done so, and keep watching the videos again and again from the playlist in order to prepare your topics well. Thank you so much. Have a nice day. Bye.